Good afternoon, ladies and gentlemen. My colleague and I, we will show you today our research on daylight at masterplan stage. I quickly start with an overview of Arup. Maybe, I guess, most of you know about Arup as a global firm working on various different projects, different sizes, globally, involving many disciplines. But I also guess that some of you only know that some of you know that we in Arup, our company, reinvests each year, a certain percentage, share of our profit in research. It's up to 10%, and this is what we do each year. So we can do this not only based with our own stuff. Some of the research projects are with our own stuff, but there's also collaboration with academic institutions, universities, and also in partnership with industry. So one of these collaborations we just started a few years ago was with Haute École d'Ingénierie et d'Architecture Fribourg. The research topic is led by Professor Raphaël Compagnon. He's not here today. But from our side, it was a collaboration between, is a collaboration between our Berlin office and the London office, led by Paula Longato. Over the past years, there has been lots of discussions with regard to the 24-hour use of daylight in cities, of light, the 24 hours use of cities, and not only related to daylight, of course, but also the main focus was on the electrical light, on the nighttime use. This is due to the fact that there's a growing economy at nighttime. But municipalities and also the lighting community, including us as Arup, we have been working and developing a lot of electrical lighting master plans, nighttime designs, etc. But when we came together with our research team, we just asked the question, why not a daylight master plan? So at Arup, about 80 to 90% of our daylight work is related to daylight projects for the interior of the projects. So there's only a few projects we do with regard to the exterior in between the buildings. So this is the reason why in end of 2014 we decided to start this research. A software tool, a daylight master plan software tool to develop it together in collaboration with the university in Fribourg. And what this image means, or what it exactly means and what it shows, will now explain my colleague Paula. She has led this, or is still leading this research topic together with the university. And I'll hand over to you, Paula.
Thank you. Can I have that thing? Okay. Yeah, I just want to give you a quick introduction of how cities are developing. We've seen in Paul's presentation a little bit of that also. I just want to tell you how fast things are happening, and that this is also an opportunity for us to act on this and provide good buildings. So what you see here is the development of New York as 1.5 centuries, more or less, to get to the stage where they are now. And if we look at Doha, for example, they're a little bit less than a decade to build everything that they have at the moment. So it's quite fast, the pace of building cities and increasing density. If we look at world population living in cities, when cinema was born in the late 19th century, we had 14% of world population living in cities. By 1965, this number grew to 24%. This is today. Half of the population of the world live in cities. And looking into the future, prognostics says that by 2050, this number will reach 70%. And that's where I think we have a great opportunity now to do the right thing. Status quo these are some images of urban landscapes that we see everywhere, more or less. Cities have been developed for cars. There are some courtyards, sometimes different densities, different cities. So, for example, Hong Kong, from the sky, you cannot even recognize the streetscape. Mexico City, also very evident as a city developed for cars. A picture of New Delhi and Rome with all the courtyards, very famous. This is an image of São Paulo, that's my home city. A very good example of how different in density a city can be, just switching from one neighborhood to the other. You have either high rise or very low constructions. The same happens to New York. If you look in the context, very high, big high-rise buildings and less dense. So I will stick with this image of New York, and we will have a look at this area because I took this as an example just to show you the new methodology we developed. Last week I found this a very interesting tool by the New York Times. They published online. It's an interactive tool. You can go there and you can check the shadows. They are mapping the shadows of New York City. So if you go there and you pass on your mouse through the shades of blue or summer. So this is a screenshot of the winter situation. But if you pass on your mouse, you see also the numbers of shadow, the time of shadow these spaces are. So they basically mapped the streets, so the open spaces, the public spaces, and some of the courtyards. So you see at this, where I pointed my mouse, is a crossing, and it's in shadow about 89% of the winter solstice. So it's quite a powerful tool also to say how much shadow there is in the city, but also to explain that when we do need the density and when we build so close to each other, the buildings. So is this a good thing? Of course, everything that we build now is based on legislation. We just heard Paul saying buildings do not pass legislation. But sometimes the legislation is just not good, or it's just not enough things about daylight in the legislation that we can build good buildings from. So the current methodology to assess daylight in open spaces or assess massing in the buildings is you take a few points, either in the facade or in an open space, and you build masking, shading masks, basically. So you understand how the massing is influencing the point you're studying. But what we want to do is basically understand the whole area, and the methodology basically takes a grid of point. We are producing for one area many masks for each of the points studied, and we are creating, and we are overlapping everything, and we are creating what's so-called a multi-shading mask. So we have an average of what's going on in the area studied, and I will show you some examples, but this can be made either in an open space, a roof, or a facade, or multiple facades. So the methodology is quite open. So in principle, what happens is that we understand which parts of the sky are being blocked by the building massing. This is the example from New York. So if you see at the upper right corner, the MetLife building was a huge building, and this area I removed the building from the model, and I said I want to study if this was to be a park, what happened in there, what kind of daylight do I get there. So I created this grid that you see here. And this is what we get as the result. On the left side, you see the resulting multi-shading mask. Oh my God, I need to run. And on the right side, you see something that has been filtered by us. So we gave some numbers. So this is what we used. So we say, well, you see that everything that is black is basically cut, all the direction of the sky that is blocked by the building massing. What's yellow is sky directions unobstructed on more than 80% of the area. So the area, all the areas see this sky direction. The green one is less than 20%, and the gray one is something in between. The numbers can be changed; it's not fixed, and this is still ongoing in the research. We can also, of course, overlay the sky path and get some. Some numbers I will show you later. So one study we recently did for a competition, and we tried to optimize. So we got this model from designers for a competition, and we studied with the building mask the area between these buildings. So what we get here is a big area where we see that the sky is being blocked. I tried to just rotating the buildings to optimize this. So you see from one to the other, it's not so good. But what I got is on the other area, I got some less less green area, let's say, my mask. Option 2 was to push the buildings apart. As we've heard, this is it's needed. We cannot build as dense as possible. So the original distance between buildings was 12 meters. And now it's the double, and we get a much better view to the sky. Yeah, so these are, let's say, image indicators that we can get using this methodology. We can also get some other numbers from the multi-shading masks. One of them we are calling the sky view factor, which is basically very similar to the view, to the VSC that we've just heard. Other interesting things that we can get the hours of probability beam, which is basically reading the sunlight, what you get in hours of daylight. I haven't shown it here, but we can also, sorry. Read weather data and get more realistic numbers out of this. This is in a facade example, same idea you can transpose to facade. And this is the multi-shading masks that we get. So I'm just showing you some examples of studies that we ran. I have to run a little bit. I have 2 minutes left. Yes. For the facades, it's quite interesting that we, I just want to point out this one, because these are the hours that we can get in the equinox. So some regulation or some guidelines say how much hours you need in the equinox of sunlight. So this is basically saying how much percent it's possible to get if there is sunlight shining. And it's quite, I think it's quite useful tool. The other numbers are the same as for the open areas. So looking into the future, we are still working on this research project. It's not something fixed completely yet. It's not finished. We are looking into having appropriate numbers for different latitudes, because we cannot say that 2% is good in Sweden, or is this the same as good as it would be in Africa or so. So we are trying to find out target values for the world. It's very yeah, it's a lot of work. We are working on it, and also we strongly believe that this methodology can be a step to change legislation and also influence decision making process to create value out of the buildings or the cities that we are creating. So yes, thank you for listening. I just wanted to show also this, as I found is a from 2001, but it relates to our very much to our research project. Thank you.
Thank you.